In this video, I will explain how to count the significant figures in a given number. Now, significant figures, sometimes referred to as sig figs, are the digits in a number that contribute to the precision of that number. Now, when you're trying to determine how many significant figures there are in a given number, there are 6 rules that you need to know, and here they are. The first rule is that all non-zero digits, so the numbers 1 through 9, they are always significant. Rule number 2 is that zeros between non-zero digits are also significant. Rule number 3 is trailing zeros after a decimal point are significant. Rule number 4 is trailing zeros in a number without a decimal point are not significant. So that's a subtle difference between rule number 3 and 4. Rule number 5 says leading zeros are not significant. And lastly, rule 6 says all digits in the coefficient of scientific notation are significant. So if you'll recall, scientific notation is like this form, where you have, let's say, some number a times 10 to the power of, say, some number b. This a right here, this is the coefficient of the scientific notation. And all of the digits in the coefficient are significant. So keep that in mind. So those are the 6 rules that you need to know. Now let's check out a few practice problems and see how we can apply these rules. So let's consider this first number here, 974. How many significant figures are in this number? Well, remember rule number 1. All non-zero digits are significant. So in this case, we have 1, 2, 3 non-zero digits. All of these digits are between 1 and 9. So all 3 of these digits are significant. So we'll say that this number has 3 sig figs. All right, now let's check out this second example, 4.1390. So by rule number 1, we already know that the 4, the 1, the 3, and the 9, they're all significant because they're non-zero. But what about this last 0 right here after the decimal point? Well, if we refer to rule number 3, this tells us that trailing zeros after a decimal point are significant. So this 0 right here, even though it's a 0, since it comes after the decimal point, it is significant. So it turns out that all of the digits in this number are significant. So we have 1, 2, 3, 4, 5 sig figs. All right, let's check out example number 3. We have the value 900. So by rule number 1, we know that this 9 is significant. But what about these 2 zeros right here? Well, if we refer to rule number 4, this says that trailing zeros in a number without a decimal point are not significant. So notice there's no decimal point right here in this number. This is just a whole number. So these 2 zeros right here, they are not significant. So it turns out that this number only has 1 significant figure. So let's write that down. All right, moving on to example number 4, we have 0.50003. How many significant figures are there in this number? So let's consider this first 0 right here. According to rule number 5, leading zeros are not significant. So a leading 0, that's just a 0 at the very beginning of a number. So this 0, this leading 0 is not significant. Now we know that the 5 and the 3 are both significant just because they're non-zero. But what about these zeros in between the 5 and the 3? Well, we can refer to rule number 2, which tells us zeros between non-zero digits are significant. So all 3 of these zeros are significant because they're in between 2 non-zero numbers. So in this case, we have 1, 2, 3, 4, 5 significant figures in this number. So let's go ahead and write that down. All right, now let's check out example number 5. We have 0.0004. So we know that the 4 is significant because it's non-zero. What about all of these leading zeros though? Well, if we refer to rule number 5, this tells us leading zeros are not significant. So none of these leading zeros, these zeros that start at the beginning of the number, they're not significant. So in this case, this number only has 1 significant figure. It's the 4. So let's write that down. All right, let's check out example number 6. We have 0.000700. So we know the 7 is significant because it's non-zero. What about all of these leading zeros right here? Well, again, rule 5 says leading zeros are not significant. So none of these leading zeros are significant. And what about these last 2 zeros right here, these trailing zeros? Well, rule number 3 says trailing zeros after a decimal point are significant. So again, these 2 zeros are after the decimal point, so they are both significant. So this value has 3 significant figures. All right, let's check out example number 7. We have 9.150 times 10 to the 7th. So if you'll notice, this number is in scientific notation. And rule number 6 says all digits in the coefficient of scientific notation are significant. So this value right here is our coefficient. So all of the digits, it doesn't matter if they're 0 or non-zero, all of the digits are significant. So we have 1, 2, 3, 4 digits that are significant. So in this value, we have 4 sig figs. And let's check out our very last example, number 8. We have 778.03500. So we know that all of the non-zero digits, let's underline those, all of these are significant because they're non-zero. What about this 0 right here after the decimal point? Well, notice that it's wedged in between two values that are non-zero. So based on rule number 2, we know that zeros between non-zero digits are significant. So that 0 is significant. So let's go ahead and underline it. And then what about these last two trailing zeros? Well, rule number 3 says trailing zeros after a decimal point are significant. So since these two zeros are after the decimal point, they're also significant. So every digit in this number is significant. So we have 1, 2, 3, 4, 5, 6, 7, 8 significant figures. So those were just a few quick examples of how to count the significant figures in a given number.